Section 6.1, Discrete Probability Distributions. Lesson objectives: distinguish between discrete and continuous random variable, identify discrete probability distributions, construct probability histograms. Lesson objective number 1. A random variable is a numerical measure of an outcome from a probability experiment, so its value is determined by chance. Random variables are denoted by using letters such as X. A discrete random variable either has a finite or countable number of values. The values of a discrete random variable can be plotted on a number line with a space in between each point. Here, and then a jump and a jump. A continuous random variable has infinitely many values. The value of a continuous random variable can be plotted on a line in which there's an uninterruption. There are no gaps. It's continuous. Determine which of the following random variables are discrete or continuous. State the possible values for the random variable. The number of light bulbs that burn out in a room of 10 light bulbs in the next year. That's discrete, and the random variable can take values from 0 all the way up to 10. The number of leaves on a randomly selected oak tree. Again, this is discrete, and the possible values could be 0 and 1 or 2, or it can go on and on and on. The length of time between calls to 911. This is continuous, and time, our random variable denoted by t, is greater than 0. Lesson objective number 2. A probability distribution provides the possible value of the random variable x and their corresponding probabilities. The probability distribution can be in the form of a table, a graph, or a mathematical formula. Let's look at a table example. The table at the right shows the probability distribution of a random variable x, where x represents the number of DVDs a person rents from the video store during a single visit. So the random variable x ranges between 0 all the way up to 5, and these are the corresponding probabilities for each of the outcome. There are two rules for a discrete probability distribution. The sum of all the probabilities have to equal 1, and each probability of the random variable has to be between 0 and 1. Is this a probability distribution? Our first step is to make sure each of these are between 0 and 1, and they are. And number 2 is the sum of all these has to equal 1, and they don't. Okay, is this one a probability distribution? And the answer is no. This is a negative number, and you cannot have a negative number in probability, so this is not a probability distribution. And then the last one, is this a probability distribution? Each of these are between 0 and 1, and the sum of these are equal to 1. So this is a probability distribution. Lesson objective number 3. A probability histogram is a histogram in which the horizontal axis corresponds to the value of the random variable and the vertical axis corresponds to the probability of that value. So we're going to look at our DVD example and get a probability histogram for that. And this is what it looks like. Here's our random variables on the horizontal, and on the vertical is our probability for each of these random variables. Here's the readings and suggested problems. Thanks for watching.